Welcome back, viewers. We were studying about the importance of AutoML frameworks, that are the automated machine learning, for the large scale social graphs, along with the network analytics associated with those kind of social graphs. And we were also discussing about the advanced aspects of social graphs, because when we go for automated machine learning, we need number of features, right, that becomes column heads in a CSV file, for example, say. So, these features could be the profile features of the nodes, or it could be the graph based features of the nodes. So, it could be the topological features like centrality features, or the degree of power law that they exhibit, or how much, what is the capability of those nodes to outreach to other nodes in the network. So, for this we need to have a closer look to different types of the advanced aspects that we have. So, we discussed about the heavy tailed property, the scale free nature of the graphs, and now we will continue our discussion on the power law behavior of the graphs. So, we had discussed that the power law behavior, that it's a very inherent property of the large scale social networks, where there are very few number of nodes that have high influence, and there are maximum number of nodes that have low amount of influential behavior, or you can say influential impact on the other nodes in the network. So, let us have a look at the implementation code for examining the power law behavior on a scale free network. So, for this once again we import the networkx library, and we take a reference variable as nx, and then we create the scale free network with n nodes and m number of edges. So, in this case n is 1000 and m is taken to be 3, and we are using the Barabasi-Albert graph once again, because for most of the scale free networks we use this graph. Apart from this, we also have the Adosh-Renyi graph and other random graphs available, but for examining the scale free network, Barabasi-Albert network, or the Albert graph, is the widely used one. Then we create the degree sequences, and you can see this is a shorthand for the for loop construct in Python, and this way we keep a count, or you can say keep a track of the number of nodes and their degrees. Now, we use this Barabasi-Albert graph because it has this capability to generate the scale free networks. Okay. And the scale free networks are basically constructed with the concept of preferential attachment. It means that all the new nodes that come and join the network, they are not always connecting randomly to any other nodes. They have a proper choice of their own, and having that preference, they are joining the other nodes in the network. So, this kind of network, they mimic the real world concepts very, you can say, near to ideal behavior is being simulated. So, that is why we use the Barabasi graphs. Now, once we have tracked down the degrees, we have to plot these degrees on a distribution graph and see how these degrees they exhibit, how this degree distribution can be plotted out. So, for this we use a log-log plot, and when you run this, when you execute this code, you will get an output like this. So, you have the degrees. You can see here that the power law behavior that we were talking about, the heavy tailed distribution, is very much widely it is visible. So, it is clearly showing that the network that we have created using the Barabasi graph is showing a power law behavior, having this scale free nature and the heavy tailed distribution. The next concept, advanced concept or you can say a very important phenomena associated with the real world graphs is the 6 degrees separation. So, for understanding this, let us dive into this theorem, which says that average path length in a graph is approximately equal to log n by log d. So, log n is what? N here refers to the number of nodes and d refers to the degree of that node. Degree means the associations, the number of associations, or you can say the direct friends or direct associations that a particular node is having. So, when we get this ratio computed, we have it very much close to 6. Okay. So, this means that any two people in the world can be connected through approximately 6 social connections. This phenomena is called the 6 degrees separation. So, there is an example which you can also carry out, which has say the world population, for example. So, it is 8.2 billion, and we are assuming that each person is having at least 40 friends in his or her lifetime. So, it could be more. In today's world, it is so much of connected that we have actually more than 40 connections. So, if you do the calculation with this statistics, you will end up getting a value which is around 6. So, as the number of associations increase, this value 6 may be a little less. So, it shows that how much connected the people all over the world are presently. So, this is the 6 degree separation and a small numerical example for that. Now, we have seen certain advanced aspects related to the graph, and we have also known that what is the relevance of network science when it comes to the large scale social graphs. Now, let us understand why we want to automate the social graphs and why we want to have the social graph analysis incorporated so that automated ML models can be used. So, as in the diagram you can see, the AutoML basically it is a pipelining design. So, we are actually accommodating all the ML tasks into a pipeline, so that these repetitive tasks need not to be designed manually every time for each ML model to be applied to the graph. So, you can have a set of ML models and they can go through the pipeline and you can have your results on the dashboard. So, what it automates basically? It automates the feature engineering like the degree distribution, as we have just seen how it is being calculated. Then other features like the centrality measures. So, a set of centrality measures you have, be it degree, betweenness, closeness, cross click, and many more such measures are there. And then the clustering coefficient, graph density. So, all these things you can have as the features of a particular graph, of a social graph. And then we do some kind of pre-processing for this, and so the pre-processing steps that are incorporated within the feature engineering phase, they are almost similar for a given set of the graphs, the interactions, the human interactions over the social network. So, for one kind of network data set, the feature engineering steps they remain same. So, why not automate it so that our manual effort is also reduced and the task, the implementation speed is also increased. And then this is followed by the model selection. So, when you select, when you have set of models, have a series of models, at 10 or 20 models you have, and then you want to pick up the best model. So, you need to apply multiple models onto your graph that is feature engineered and pre-processed and all. And then comes the hyperparameter tuning, and finally we validate the model with post visualization techniques and several other statistical tests. So, after the automated machine learning framework is applied, then we can systematically examine which model is the best fit. Okay. So, for this we have certain data available on the dashboards, because when we go for these AutoML frameworks, there are several AutoML frameworks available. So, AutoGluon is one of them, PyCaret is also another one, then H2O is there. So, this way several AutoML models are there, and for each AutoML model you will have a dashboard that showcases that what are the different models that were applied and what are the time of their execution to fit the model to do the prediction, and what was the accuracy, precision, F1, recall. So, all these things they come on a dashboard. Sometimes they are called the dashboard, sometimes in some of the cases they are also called the leaderboards. So, this greatly reduces the burden of the repetition of the ML related tasks, and also as we discussed some time back that there are several research teams, and the research teams are mostly having interdisciplinary people with different types of skills available. So, it is not necessary that everyone is a ML expert. So, this kind of automated ML becomes very helpful for the interdisciplinary research teams. So, different AutoML libraries, as I was saying, are available for different types of tasks. So, if you are preferring a node classification, then you can have Teapot, AutoGluon, and you want to have the tabular view of the results. So, these two are very useful. You also have AutoSKLearn for node as well as for graph level classification. And also, if you want to use explainable AI after you have applied the AutoML framework, then H2O is again a very useful library available to us. Now, coming to the AutoGluon leaderboard. So, let us take one of the example of the leaderboards from AutoML, which is called the AutoGluon. So, in AutoGluon, when AutoGluon is executed, we will see a small code snippet of this as well. So, in this what happens, the model that is being used, the name of the model, the trained model that comes, then associated with each of the model we get the score val, that is the validation score. It can be set to either accuracy, F1 or like that. So, it's basically an internal validation when we do the model training. Then there is also this score test that is it's a performance score that comes up when the user supplies the test set. So, very sure that you are aware of the fact that whenever we are doing a machine learning training, model training, then we split up the initial data set into a ratio of say 70-30 or 80-20, where the 80% is given for the training purpose, for training the model, so that the model can run based on the learned the inherent qualities, the behavior that the training data set has, and then it applies the trained model over the test data. So, we assume that the test data, the ground truth reality associated with the test data is not available to the model, and then we try to compare the model prediction and the test data target variable. So, I am taking this from a classification example, let us suppose. So, what else are associated with AutoGluon leaderboard? We have the evaluation metric, we have the prediction time, and the prediction time could be like it is expressed in seconds, and it could be of the validation set as well as of the test sets. Then there is also something called the fit time and the prediction score test. So, all these things they come in the AutoGluon leaderboard. Now, let us understand what is the workflow of AutoGluon AutoML library. So, AutoGluon starts with converting the graph features into a tabular format. So, whenever we have a graph structure or a network kind of a data set, what is the first step that we want to do? We want to convert the graph into a tabular format, or simply told, it is a CSV file for ML readability. And then we try to add the labels for the, say, the supervised learning tasks. For example, bot detection or influence prediction. For example, in the bot detection, we just want to know that whether a profile is a bot or a not bot. Okay. So, this way there could be different labels associated. So, we need to have the labels. So, first we are creating out the tabular format of the particular graph, and then we are labeling out. So, these labels could be either binary, 2 labels, or it could be 3 labels. So, likewise we can have a multi-class classification with automated machine learning framework. And after this is done, the data set is prepared with the target variable. Then we go for creating the machine learning pipeline. So, we have these features, we have these graph based features. If in any case it is difficult for you to get the graph features, we can also go for the graph embeddings. And then we do the feature engineering, and finally we provide the labels wherever it is possible, and then we set out the evaluation matrix, that based on which metric we want to evaluate, and comparative analysis has to be carried out for the ML models. Then we may apply the explainable AI models to interpret the results. So, this becomes optional. Not all AutoML frameworks, they provide this extendability towards the explainable AI. So, there are certain AutoML frameworks like H2O, they have this capability to incorporate explainable AI or XAI after the best model is chosen. So, if we take up a case study with a very famous benchmark network dataset of Karate Club. So, this figure shows the Karate Club with the nodes that are in a bigger shape. They are basically the nodes with higher betweenness. And for this we need some Python libraries, like since it is a network, so we have to take the network X, and then the pandas, because we are tabulating the graph based the graph based data, the details, everything into a tabular format. So, pandas, and since we are using visualization libraries as matplotlib and seaborn, and they are built over NumPy library, so NumPy is also included, and our AutoML framework which is AutoGluon in this case. So, we can pip install each of these libraries separately, or we can do it in a single line. So, it is a shorthand. You can pip install and you can write the names of all the libraries space separated. Once the libraries are installed, then we import those libraries. So, you can have the import statements, and this is basically the snippet for using the, or you can say applying the AutoGluon for Karate Club. So, as I told that there has to be a label, because we are having this for classification task. So, whenever it is a classification, it needs to have a class or a label. So, this label, it forms as a ground truth reality. So, this Karate Club, it inherently it has a club label, that it belongs to one club or another. So, you can use that label directly, or you can inherently if you want, you can label it of your own, or label it based on some semi supervised learning method. And once you have the label, then you apply the AutoGluon. So, tabular predictor, it is the AutoGluon predictor, which can be used to fit the model. Okay. And once you have the tabular predictor predicted all those, using a list of ML models with the target being the label in our case, and train DF is the that 80% of the data set that is used for training purpose. So all these things are there in this variable predictor. Now, after the models are built, so it's not one model that is built, it's a set of models that are trained. Now we have to, we are in a position to choose that which model is best. So to assess the best model, we can do a comparative analysis, and this comparative analysis things, this can be taken out from AutoGluon using predictor.evaluate test df. So we have trained the model using the train df. Df is basically used for the data frame. So you have the train df for training the model. Now we are using the test df to test the predictor and evaluate the performance. And then we can use this predictor dot leaderboard and then predict the outcome. So on the screen you can see the outcome. So this is the set of results that we get from the AutoGluon AutoML for the Karate Club network. So in the beginning you can see, you have seen that the Karate Club network is pretty small, and you can have your own network, your own CSV file having the source and the destination and other topological and profile centric parameters, and you can train your own AutoGluon to get this kind of results. So in each row you can see that these are the different models that are available, and the beauty of the AutoGluon is that, or any other AutoML that you may be experimenting with later, you will see that these are mostly the ensemble stacked models. So those that are L1 in the prefix, it means that it is the base model, and if it is L2 or L3, it means that it has been ensembled and stacked. So different types of multiple bagged models are used. So bags are what? It is nothing but the random subsets on which the model is trained. So all these things are done to reduce the overfitting. So whatever result you get, if it is even if it is like more than 95% or something, then it makes sure that it is not a model overfitted results. So this is the main advantage of the AutoML frameworks, the AutoML libraries. Now let's have a look on when to use AutoML and when not to use AutoML. So this is a very important question, because when we have AutoML with a series of so many models, why not always go for it, or exactly when we have to use it. So the do's and don'ts, it comes with all kind of things in the real world. So why not AutoML? So for AutoML, the first thing is it needs the pre-computed node level features. Okay, so if you are not having the pre-computed node level features, then it will become really very difficult to apply AutoML, because being ML, it requires a file that is ML readable file. Okay, so if you have the node level features, the interaction features, the graph based features, then it's fine. Otherwise you can go for the graph embeddings, and you can have different types of graph embedding libraries available to convert a network data set into a CSV format using Node2Vec, DVOC, etc. What is the other thing that mandates? That is when we want to do a rapid prototyping, and we don't want to enter into manual tedious coding of each and every ML model, because all the ML models, the steps, the pipelines that are being followed are same. So when you have a large scale network and you want to test a large number of ML models over that network, then it is always preferable to go for the AutoML, and also preferably when you have a lot of interdisciplinary skilled people and they are not only the ML skilled people. So it becomes very easy to make understand even those who do not have the skill for the ML code programming, they will also get to understand and examine the leaderboards like the one that we have just seen for AutoGluon. Now, when not to use AutoML. So, when practically we do not have those kind of node level features, and which are those cases when it's very difficult to have the node level features. It is for the heterogeneous graphs, it is for the knowledge graphs. So, it becomes very difficult when you have the knowledge graphs built, because these are the graphs that are built with different contexts. Okay, so multiple contexts are there. So, as many multiple contexts you have in the graph, it will become difficult to quantify them into a tabular format. If you can, if you find a way out, then you can definitely go for the AutoML. The other one is if the data set is really very small. So, machine learning is always applicable when you have a larger data set. So, if you have a very small data set, then it is recommended not to go for AutoML. Otherwise, there could be the overfitting problem associated with whichever model you are using. And also, these AutoML models, as you have seen, a lot of stacking, bagging, and sampling, it goes on. Hyperparameter optimization, different rounds of, multiple rounds of optimizations also go on. So they also tend to take a lot of computational resources. So if you think that you are lacking in the computational resources, then also you may prefer not to use AutoML. Now, these are some of the system configuration that you can see for AutoML. Okay. So, these are basically the, in terms of CPU, the processor, the memory, the storage, and the operating system configuration. So, you can see there is a section of minimum configuration required, which is a green go ahead. You can go for AutoML computation, machine learning frameworks, or if like you do not have it, you can try to upscale and make use of it. So, recommended ones are the most promising ones, which definitely supports for high performance results, and you do not have to wait for hours to get your results. So, these are the system configuration that you can use, or you can say you can refer to when you are using for AutoML. Now, these are the references to the further research. So, you can see that on the top we have some official documentations. So, what are these official documentations? These are very useful when it comes to the understanding of the libraries. So, for example, we have used AutoGluon. So, through this lecture, I have given a small code snippet of the AutoGluon AutoML. But if you want to enter into more, practical implementation of these libraries, you can definitely go to the official documentation. So, each of the Python library has its own documentation. So, AutoGluon also has its own, so you can refer to the same. And then there is H2O also, as I was telling that H2O is one which helps you to have an idea of how the explainable AI can be incorporated along with AutoML. So, you can refer to that, and some other articles are there that you can refer to. So, many thanks for listening to this discussion on AutoML, network science, and the social graphs. Thank you.